Hello, everyone, and welcome to Backer Breaks It Down. In this episode, we are looking at congruent triangles. We are going to focus on identifying corresponding sides and corresponding angles of congruent triangles, and we're also going to throw a little bit of algebra in there, because why not? Congruent triangles are triangles that have the same shape and size. Each triangle has 3 angles and 3 sides, and if all 6 pairs of corresponding parts are congruent, we can say that the triangles are congruent. Now, we can easily identify corresponding sides and angles using a congruent statement. So here we have triangle ABC is congruent to triangle EFG. Now the order of these letters is important because the order will tell us which pairs of angles are corresponding and thus congruent, and also which pairs of sides are corresponding and thus congruent. For example, angles A and E are congruent, and notice that A and E are the first letter in each of the triangle names. We can also use the congruent statement to identify congruent segments. So they say A, B, and E, F. So if you look at the congruent statement, notice that A, B are your first and second letters. E and F are also the first and second letters. So order is important because it's really going to tell us a lot about the corresponding parts of our congruent triangles. So let's see if we can create our own congruent statement and identify all of the corresponding and congruent parts. Now, when you write a congruent statement, you can name the first triangle any way you like. So I'm going to call the first triangle, sorry, my pen's not working. There we go. I'm going to call it triangle LJK. I kind of did this on purpose because when I looked at the diagram, I saw that angle L had that single arc mark, J had 2, K had the triple arc mark. So that's my reasoning behind how I named it. But you can name that first triangle any way you like. Because I named the first triangle LJK, I need to make sure that I name the second triangle in such a way that it corresponds to it. And that's, like I said, angle L had that singular arc mark. Well, notice that R also has that singular arc mark. So it's like I know that angle L is congruent to angle R. I also know that R should come first in my name over here. Next, I have angle J. In my diagram, I notice that angle J has that double arc mark. Angle T has the same markings, so that will come next. And lastly, we have K. K has the triple arc marks, so does angle S. So the order matters. You can name that first triangle any way you like. The second triangle must follow that order you've established. So I kind of did 2 things here. I wrote my congruent statement. I also identified my corresponding congruent angles because why not? What about corresponding congruent sides? So I can just pay attention to the ordering of my letters once again. So like LJ, RT, those would be corresponding and thus congruent sides. Okay. Another pair of corresponding congruent sides, I can go, let's write again, JK and TS. And then let me get a different color now. And then if I went with like LK, I'd go with RS over here. So once again, the congruent statement really allows me to keep everything in the proper order. I can also use the congruent statement to help me in problems like this one. So like in this diagram, I know that triangle MNP is congruent to triangle TUS. I want to find the values of X and Y. When I look at my diagram, I notice that here's X and Y, it's representing side NP, and then I have another expression with X representing U. I feel I should start with the 2x minus 50 since there's only one variable there. Now, when I look at my congruent statement, angle U is that middle letter. So the congruent statement helps me to easily identify the angle that U is congruent to. U is in the middle, N is in the middle, so I know that angle U is congruent to angle N. Now, angle U has the measure of 2x minus 50. What's the measure of angle N? Well, at first glance, it's like, I don't know, but we know. We just have to find it. Remember that triangle sum theorem says all three angles of a triangle add up to be 180. So I know that one of the angles is 142, the other one is 24. So if I go 180 minus 42 minus 142 minus 24, I get that missing angle is 14 degrees. Okay, so here's my equation, and then I can solve it for x, and I can get 32. Once I know that x is 32, I can now find the value of y. Because remember, they said that NP is 2x minus y. According to my congruent statement, I know that NP is congruent to US. So NP is the 2x minus y. US is 13. And we do know that x is 32. So 2 times 32 minus y is 13. And so if I go and solve this, I end up with y is equal to 51. But the congruent statement is definitely helpful in problems like these where you have to create equations using those corresponding congruent parts. Okay. And so there you have it. Congruent triangles are triangles that have the same shape and size. Each triangle has three angles and three sides. So all 6 pairs of these corresponding parts would need to be congruent for us to say the triangles are congruent. And the congruent statement can totally help us identify which pairs of angles are congruent and which pairs of sides are congruent. And that's how Bakker breaks it down.